All right, we're back. We're on page 3 of notes 10 of Calc AB. We are talking about derivatives and function analysis. Like function analysis just means, is there a maximum, a minimum, a point of inflection? Do you know what that is yet? Maybe, maybe not. But so far we've talked about if f prime is positive, the function's increasing. If f prime is negative, the function is decreasing. We talked about the first derivative test, which tells you if f prime changes from positive to negative at a point, then the function changes from increasing to decreasing, you must have a maximum. If f prime changes from negative to positive, then the function changes from decreasing to increasing, you must have a minimum. So it's kind of like a common sense type of thing, but common sense isn't always obvious, right? Common sense is one of those things where once you've acquired the knowledge, you look at it and you're like, duh. But until then, maybe not. All right, find the critical points, which means the points in the domain of the function in which the derivative is 0 or undefined, and classify them using the first derivative test. All right, so I'm going to do this by taking the derivative, using a bunch of chain rule and product rule. Then I'm going to make a sign chart. Then I'm going to use the sign chart to draw conclusions. And then I'm going to write them up correctly. So let's see if we can do that. So f prime, we got first, derivative of the second. So it's going to be 3, but then you get another 2 from the chain rule. So 6, 2x minus 1 squared plus 2x minus 1 cubed. All right, so it's going to be 2 when you pick up a 1 from the chain rule, so nothing really. 2 times x plus 3. All right, so when you factor these, you factor by grouping pretty much. Factor by greatest common factor, I think, is what you do. So like there's this and this. So I can take out x plus 3 for sure. I can take out 2 x plus 3 to the first. I can take out, so where did the 2 come from? The 2 came from 6 and 2 have a common 2, right? And then from, I need another color. Here we can take out 2x minus 1 squared actually. So let's do that, 2x minus 1 squared. All right, what are we left with? Well, we're left with 3 from this. This is all gone. And then one of these, so 3x plus 9. I'll probably check these on the calculator. It's easy to make mistakes on these, especially when you're talking your way through it instead of just like going for it. All right, we took out, the 2 is gone. We took out this. We took out squared, so we just have 2x minus 1. 2x minus 1. I would say that like 85% of the mistakes that I make in my videos are because I'm talking my way through the problem instead of just doing the problem. It's like a different place in your brain where you keep like both of those pieces of information. Okay, so look at this derivative. When you're taking the derivatives of these things, you always get like 2 of the critical points for free. And then there's always like a secret one, or you get like as many as there are factors up here. Like if there are 20 factors, you get 20 critical points for free. But then there might be like, I guess 19 hidden ones. There's always hidden ones. And the way that you find them is by actually taking the derivative, actually factoring the derivative, actually simplifying it. So I'm going to check this on the calculator just to make sure before we dive in. So let's see, calculator page, go. And I'm just going to say derivative. You should use the derivative template. It's easier for me to type it. X plus 3 squared, 2x minus 1 cubed, and with respect to x. So 5x plus 8. Good. All right, let's go back. And we'll do a sign chart now. So sign charts, I don't know if you remember, in like algebra 2, you talk about polynomials. Well, maybe in pre-calc, depends on where you learn it. You talk about polynomials and like, you know, does it bounce? Does it pass through the axis? Like what's happening? I feel like a lot of that is so you can do this analysis right here. So we're going to make a sign chart. So you start with basically a number line, f prime. All the zeros or the places f prime are undefined is f. The zeros and places where f prime is undefined. That goes on the number line. So -8/5, -3, 1/2. They have to go in order though. So, well, though, as if that's like a surprise. I see a lot of people put them not in the right order and then you get the wrong conclusions. Okay, so now we got a test. -1 billion, let's say. I mean, this is obviously positive. You're gonna get negative. This is gonna be positive because you're squaring it. So you have negative negative. So that's 2 negatives, so positive overall. And we put a bunch of them. Now you got your options. Do you remember polynomials really well? If you do, then you know that everything that's to an odd power is going to have a sign change. So I know that the next thing I'm going to write is this. If you don't remember that, test something else. What's in between -3 and -8/5? I guess -2 is, right? So that would be a positive, and a negative. Positive, positive, negative gives you negative overall. So that's what I was expecting, but it's a good check. This is from a first degree thing, so I know there's going to be a sign change, so I know that we're going to be putting pluses. But if you're not sure, 0 is in between them, and that's always a good choice. Positive, 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 positive overall. Then, if you test a billion, which I think is always a good choice, positive, 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 or this is a second degree thing, so there won't be a sign change. If it's second, fourth, 10th degree, any even power, you're not going to get a sign change. So we knew we would get pluses here, but we checked it anyway. All right, so this is f prime. You can add, so I don't really add this, but you can say that therefore f is increasing, decreasing, increasing, increasing. It's harder to mess it up when you do that. So like probably a good idea. In general, it's a good idea to do problems in such a way that it's harder to mess them up than it is in other ways, but whatever. All right, so what do we want to say? F of x has relative maximum at x equals -3 because, how much space do I have here? F prime changes from positive to negative there. And then f of x has a relative minimum at x equals -8/5 because f prime changes negative to positive there. I'll put it down here. There you go. That's your first derivative test justification. Use it. Don't freelance. Don't try to come up with your own thing. Just use this. The only change that I might make to this, which people usually ask about, and I do not know what my mental logic is on this, you might say f prime of x and f prime of x. Like, it feels like that should be there. Now, we're also just straight up ignoring this because the first derivative test does not allow us to classify it, right? Use the first derivative test to classify. Does it say find the critical points? Oh, it did say find the critical points. I'm going to move this down a little and answer that, which I should have done before. And I apologize if you're like strictly following along. I don't know. My notes are going to look not that great. Your notes are going to look not that great. Mine are going to look fine because I can move things. So critical points, CPs, x equals -3, x equals -8/5, x equals 1/2. Now those are all critical points because f prime is equal to 0. There's no place f prime is undefined because f is a polynomial in factored form. Polynomials are defined everywhere. And they're smooth and they're continuous, and that's why they're some of the best things to work with. All right, let's do this one, and then I'll call this a video, and then we'll do whatever. And we'll do the rest of the page in the next video, not whatever. 2x plus 5. All right, so you get a 2 from the power rule, a 3 from the chain rule, so it's going to be times 6, 3x minus 1, plus 3x minus 1, and you just get times 2, because that's just a linear factor. All right, so what can we take out? We can take out a 2 for sure because of those. So 2. And then you can take out 3x minus 1. So you should. 3x minus 1? Oh, squared. Yeah, it's not possible for them to be at the same degree. So like it was pretty clear to me that I had messed something up. So we're going to take out 3x minus 1 to the first. And then what are we left with? Well, we're left with a 3 here and this. So that's going to be 6x plus 15. Don't close that. And then here we are left with, we took out this and we took out one of these, so just 3x minus 1. So there's our, well, you don't see it yet, but there's our hidden critical point. So f prime of x is 2, 3x minus 1, and 9x plus 14. Okay, critical points. Critical points. X equals 1/3. X equals negative 14/9. Like nobody's wondering how you got those. If you want, you could say critical points where f prime equals 0 and then say x equals 1/3, x equals negative 14/9. I don't think anyone's going to give you trouble about just like looking at that and saying those are my critical points. Who knows? Sign chart. So what do we know here? If I expanded this, this would be a positive cubic, right? Because it's like 9x squared times 2x, so it's like 18x cubed. It's basically 18x cubed. 18x cubed basically looks like this. So like I kind of know my sign chart based on this, right? Increasing, decreasing, increasing. So I'm gonna go positives, negatives, positives. That's what I think is gonna happen. And I think it's useful to like think that through so that you can kind of have expectations. And it's especially helpful when you mess up. That's when it's really helpful to have thought it through. All right, negative a billion. Negative a billion gives me a negative, so positive overall, which is what I was expecting. This is from a first degree factor, so there will be a sign change, or we could test 0, negative, positive, so negative, got negative that we expected. This is from first degree, so there will be a sign change, or we could test a billion. A billion will give us positive, so definitely positive. Okay, let's write our answer. F of x has, so f prime goes positive to negative, f of x has a relative maximum because I don't know what I said. F prime goes positive to negative, so f of x has a relative maximum because f goes from increasing to decreasing. So f of x has a relative maximum at x equals negative 14/9 because f prime, let's do the of x, f prime of x changes positive to negative there. Okay, and now we'll do 1/3. F of x has, so typically, I mean, they basically, like, when you're listing them from left to right, they kind of have to alternate maximum, minimum, because you're skipping where it doesn't have anything. Like if we had another critical point where we just went negative, negative, it's not a max or a min. And a function like a roller coaster has to go from maximums to minimums to maximum. Like it has to alternate. You can't have like a maximum, then another maximum, because like then the previous one wasn't a maximum. So you know this is going to be a minimum, is what I'm saying. But you know, that's experience, and you got to do a lot of problems to get it, because f prime of x changes negative to positive there. All right, there we go. I'm gonna check, what am I gonna do? I'm gonna check both of these on the calculator, I guess. You don't really need to. Well, I mean, you should, because you can. So I'm gonna do it because I can. I'm gonna say f of x, you know what I'll do? I'm just gonna graph them both. So first I'll store this, and then I'll call the other one g of x is 2x plus 5, forgot an x, and then 3x minus 1 squared. All right, add a graph page. So I'm gonna graph f of x, and f of x, I'm expecting to see the behavior. I think I want a maximum at -3, a minimum at -8/5, nothing at 1/2. So let me zoom out. Oh, let me zoom out. Let's just window this thing. So -3, if I go like -5 to 5, and then go like, I don't really know, -100 to 10, looks like it would kind of, ooh, not even. Okay, where is this minimum? I mean, I could figure it out. I think the minimum's at -8/5, right? So let me do this. Settings, there. I'm gonna do f of -8/5 minus 30. And then the maximum, well, the maximum could be anything because it keeps like growing forever to the right, but let's see. That worked out really nicely. Ooh, that's an exact, no, yeah, okay, that's an exact value, but not the exact value of the minimum. My excitement kind of boiled over there for a second. Maximum should be at -3, which it is. Minimum should be at -8/5, which is -1.6. And then I'm thinking there's a point of inflection at 1/2. So I'm going to ask the calculator if there is. Option 5 is inflection point. And there is. So a lot of critical points that show up early, I think of them as showing up early and they don't have a sign change. They're very often going to be points of inflection. So if you're not super familiar with a point of inflection, it's where the curve goes from, imagine the tangent line, right? The tangent line is going to be above the curve, above the curve, above the curve. Then suddenly the tangent line is now below the curve. Like what happened there? Point of inflection is what happened. So we're going to talk about those, but also notes 22, math analysis, it's all in there. G of X. G of X is boring. Let's zoom out. My go-to is to zoom out a bunch and then to zoom box, but like these curves are not great for that, it turns out. This is what I like to do. Zoom and then box. And then, because you can keep going and just get like a nicer picture. But plenty nice. All right, menu 6. We want the minimum. I think the minimum is at 1/3. Yes, it is. And then we want the maximum, which I think is at -14/9, which I will see what the decimal says and see if I think that's -14/9. -9, yeah, I think that's -14/9. I believe so. -14/9. Yeah, got it. Okay, go back to the notes. We're going to stop the video here. We'll talk about the next part of the video, next part of the page, I should say, is all like talking and thinking. But I'll be back in the next video to do that. So anyway, this is the first derivative test. These are great model problems. Make your work look like this, and you will be doing a great job. So I'll see you in the next video.